Hello, this is section 9.8, solving quadratic and rational inequalities. Part 1, applications involving proportions. Finding test intervals. When working with polynomial inequalities, it's important to realize that the value of a polynomial can change signs only at its real zeros. The zeros of a polynomial partition the real number line into intervals. So for example, if we had the inequality x plus 2 times x minus 3 is greater than 0, the real zeros of this polynomial are x equals negative 2 and x equals 3. So that if I took my number line, we would have negative 2 and 3 would split the number line into 3 intervals. We would have negative infinity to negative 2. We'd have negative 2 to 3. And we would have 3 to infinity. So that's what we mean that splits it into intervals. Finding test intervals for polynomials. Find all real zeros of the polynomial. The zeros of polynomials are called its critical numbers. Use the critical number / roots to determine the test intervals. Choose a representative x value in each test interval and evaluate the polynomial at that value. If the output is negative, then the polynomial will be negative for every x value in the test interval. If the output is positive, then the polynomial will be positive for every x value in that test interval. Sometimes instead of saying positive and negative, I will say false and true. And instead of saying a representative x value, it is very common to say a test value. Quadratic inequalities. Solve the following inequalities. Part A, x squared minus 5x is less than 0. So again, we need to find the zeros of this. So I'm just going to rewrite it as x squared minus 5x is equal to 0. That's what we're looking for. So that would be x times x minus 5 is equal to 0, which means x equals 0, or x minus 5 equals 0. Add 5 to both sides of the second equation. We get x equal to 5. So our two zeros are 0 and 5. Next, I'm going to do my number line. I have 0 and 5. Now I'm going to pick my test values, and they can't be one of my zeros. So for example, negative 1, 1, and 6. So because it's split into 3 regions, I need 3 test values. Notice how instead of putting a tick mark, I'm putting an X for my test values. That's so that I don't forget what the test values are. Another thing I do is I usually draw a dashed line where the test values are to really split it up. So now let's plug negative 1. Now you always plug it back into the original inequality. So we get negative 1 squared minus 5 times negative 1, which is 1 plus 5, which is 6. Is that less than 0? That is false. And then I'll even put that on my number line. And then plug 1 in. 1 squared minus 5 times 1, which is 1 minus 5, which is negative 4. Is that less than 0? Well, that is true. And then plug 6 in. We get 6 squared minus 5 times 6, which is 36, minus 30, which is 6. Is that less than 0? Nope, that's false. So then we'll get false. Then, how do we report our answer? Well, our answer is the interval in which it was true. So our answer, well, we only have one true interval here. It's 0, 5. Now, this is where you have to look at your inequality. We had a strict inequality here, which means it cannot equal 0. So we're going to use parentheses on both endpoints. Part B, 2x squared plus 5x is greater than or equal to 12. So again, I'm going to find the zeros of this polynomial by making an equation. So 2x squared plus 5x is equal to 12. Subtract 12 from both sides. Get 2x squared plus 5x minus 12 is equal to 0. And then I'm going to try to factor this. Let's see if it's factorable. Negative 24, 5, 2x, 2x. What two numbers multiply to negative 24 and add up to 5? Well, that's 8 and negative 3. And then this one will reduce to x over 4. So we get x plus 4 times 2x minus 3 is equal to 0. So we get x plus 4 equals 0, or 2x minus 3 equals 0. So we get x equals negative 4, or x equals 3 halves. Next, I go to my number line. I get negative 4 and 3 halves. Again, my number line is being split into 3. It doesn't have to be. You can split the number line into more pieces. Just in this class, it's primarily 3. And now I need my test points. So I would probably say negative 5, 0, and 2. Now plug those in. So we get 2 times negative 5 squared plus 5 times negative 5, which is 50 minus 25, which equals 25. Is that greater than or equal to 12? That is true. Then we get 2 times 0 squared plus 5 times 0, which that'll equal 0. Is that greater than or equal to 12? That is false. And then we have 2 times 2 squared plus 5 times 2, which is 8 plus 10, which is 18. Is that greater than or equal to 12? That is true. So notice now my answer is going to have 2 intervals in it because I have 2 true intervals. So I have negative infinity to negative 4. And then we have 3 halves to infinity. Well, remember, infinity always has a parenthesis, so that's going to be parenthesis. But now this time, the inequality is a loose inequality because it has an equal to sign. So that means I'm going to use brackets. And whenever you have multiple inequalities, we have to connect them with the union symbol. Part C. Negative x squared plus 6x minus 7 is greater than or equal to 0. So again, find your critical points. So negative x squared plus 6x minus 7 is equal to 0. I'm actually going to divide everything by negative 1 because I like my leading coefficient to be positive. So we get x squared minus 6x plus 7 is equal to 0. And if you try to factor this, it's not factorable. So you can either complete the square or quadratic formula. I'm going to complete the square. So subtract 7 from both sides. get x squared minus 6x equals negative 7. And then take half of negative 6 squared, negative 3 squared, 9. So I'm going to add 9 to both sides. Then the left-hand side factors is x minus 3 squared is equal to 2. Take the square root of both sides. We get the absolute value of x minus 3 is equal to the square root of 2. So we get x minus 3 equals square root of 2, or x minus 3 equals negative square root of 2. And then add 3, we get x equals 3 plus the square root of 2. Add 3, we get x equals 3 minus the square root of 2. So now I just need to make my number line. So we have 3 minus the square root of 2 is going to be smaller than 3 plus the square root of 2. And now to pick my test points. 3 minus square root of 2. I believe that's like 1.6, 1.5, something like that. So just to be safe, I'll pick 0. And since this is 3 minus a number and 3 plus a number, exactly in the middle of them would be 3. And then again, about 1.5, so just to be safe, I will pick 5. Now we need to plug those in to the original inequality. Don't forget, always plug into the original. So negative 0 squared plus 6 times 0 minus 7. Well, that's equal to negative 7. Is that greater than or equal to 0? False. 3. Negative 3 squared plus 6 times 3 minus 7. That is equal to 2. Is that greater than or equal to 0? True. And then negative 5 squared plus 6 times 5 minus 7. That is equal to negative 2. Is that greater than or equal to 0? False. So we get false, false, true. Oh, I forgot to draw the dashed lines. Again, that's just for a visual thing. It's not really required, though. And now our final answer. Well, we only have one true interval again, so it's 3 minus the square root of 2 to 3 plus the square root of 2. And looking at the original inequality, I see it's a loose inequality, which means it has an equal to sign, so it's going to be brackets. And that's a good place to stop for this first video.